If the whole Earth were to be seriously affected by a single natural disaster, where do you think it would come from? While many people may say an asteroid, let's take you to a location on Earth that isn't even likely a candidate. That will take us to the US, which you can see on the map in red. As you may have guessed, it is Yellowstone National Park. Many people see Yellowstone National Park as a marvel of nature to be visited and admired. But what the millions of visitors don't know is that they are standing on a site that can change the world in a matter of hours and force humans to cope with extreme weather conditions. Supervolcanoes are likely to have killed more people than asteroids. Although it was previously believed that these massive volcanoes would take thousands of years to build and remain trapped beneath the Earth's crust for an equal number of years before having any impact on the globe, new evidence suggests otherwise. A new study suggests that these catastrophic eruptions, thousands of times more powerful than Mount St. Helens' 1980 eruption, might happen at any time now. Officials at Yellowstone National Park have discovered that a sizable piece of magma has begun to pulse. People are currently wondering whether or not this ticking time bomb will burst. Could it erupt within our lifetimes? If it does, why is a significant portion of Yellowstone pulsing? Is humanity on the verge of an apocalypse? Could a supervolcano be on the verge of erupting? Is it true that what would bring about the end of humanity lurks just under our feet? Few things are as awe-inspiring as volcanic eruptions. They can't even be stopped or prevented. But what is a volcano, and how does one erupt? Let's dive into a bit of interesting geography. Many mountains form by folding, faulting, uplifting, and erosion of the Earth's crust. Volcanic terrain, however, is built by the slow accumulation of erupted lava. The vent may be visible as a small bowl-shaped depression at the summit of a cone or shield-shaped mountain. Through a series of cracks within and beneath the volcano, the vent connects to one or more linked storage areas of molten or partially molten rock, or magma. This connection to fresh magma allows the volcano to erupt repeatedly in the same location. In this way, the volcano grows ever larger until it's no longer stable. Pieces of the volcano collapse as rockfalls or landslides. When molten rock below the surface of the Earth rises through volcanic vents, it is known as magma. However, after erupting from a volcano, it becomes lava. Magma is made of molten rock, crystals, and dissolved gas. Picture an unopened bottle of soda with grains of sand inside. The molten rock is made of the chemicals oxygen, silicon, aluminum, iron, magnesium, calcium, sodium, potassium, titanium, and manganese. After cooling, liquid magma may form crystals of various minerals until it becomes solid and forms ores or magmatic rock. Originating at many tens of miles beneath the ground, magma is lighter than surrounding solid rock. It is driven toward Earth's surface by buoyancy because it is lighter than the surrounding rock and by pressure from gas within it. Magma forces its way upward and may ultimately break through weak areas in the Earth's crust. If so, an eruption begins. Magma can erupt in several ways. Sometimes, molten rock pours from the vent as fluid lava flows. It can also shoot violently into the air as dense clouds of rock shards or tephra and gas. Larger fragments fall back around the vent, and tephra clouds may move down the volcano's slope under the force of gravity. Ash, tiny pieces of tephra the thickness of a strand of hair, may be carried by the wind, only to fall to the ground many miles away. The smallest ash particles may be erupted miles into the sky and carried many times around the world by winds high in the atmosphere before they fall to the ground. So, how many volcanoes are there? The U.S. Geological Survey, USGS, tracks over 160 active and potentially active volcanoes in the United States alone. There are about 1,350 potentially active volcanoes worldwide. About 500 of these have erupted in the past 100 years. Many of these are located around the Pacific Ocean in what is known as the Ring of Fire. When visitors to Yellowstone in the U.S. tried to report what they saw during their visit, local newspapers accused them of lying and said they were not in the business of printing fiction. Nobody could believe the tales told by these mesmerized visitors to what is now known as Yellowstone National Park, the first of its kind in the U.S. From colorful hot springs to mud pots, breathtaking waterfalls to geysers, it's easy to see the newspaper's point of view because nowhere else on Earth packs as much wonder in a single place as Yellowstone. Everybody sees something that fascinates them. Yellowstone was established in 1872, making it exactly 150 years old, and it has remained one of the most visited national parks in the country, welcoming almost 5 million visitors last year from every part of the world. The park sits in 3 states but is mostly located in the state of Wyoming. It spans about 3,500 miles, which means countries such as the United Arab Emirates and Gabon are only about 10 times larger. Yellowstone could swallow sovereign states like Brunei, Luxembourg, and northern Cyprus and nearly fit Lebanon and Gambia. Yellowstone National Park is actually located on top of a dormant volcano, but visitors can enjoy the geysers, which are more concentrated here than in any other place on Earth. Other wonders in Yellowstone include the Yellowstone Grand Canyon and wildlife, including America's largest buffalo herd, grizzly bears, and wolves. Approximately 50% of the world's hydrothermal features are at Yellowstone National Park, creating an effect that makes the ground appear to be on fire. The most famous of all these geysers is Old Faithful, one of the most popular and recognized natural wonders in the United States and known the world over. When you plan a visit to Yellowstone, you'd better come with your camera. But there's something else scientists have found out about this park that you should know, even if you don't plan to visit. This is because, no matter where you are, the discovery will affect you and your family. Remember, Yellowstone sits on a dormant volcano. Well, dormant volcanoes sometimes become active and explode. Yellowstone's volcanic eruption is a distinct possibility. So, what happens if Yellowstone erupts today? It is going to be ugly for everyone. To really understand what we are dealing with here, we will go back about 2.1 million years when it erupted for the first time and about 1.3 million years when it erupted again, with devastating consequences. In each of these cataclysmic events, Yellowstone sent up enormous volumes of magma from the surface and into the atmosphere. The eruption contained mixtures of red-hot pumice, volcanic ash, or small jagged fragments of volcanic glass and rock. It also included gas spreading as pyroclastic flows in every direction. As a result of the rapid withdrawal of such large volumes of magma from the subsurface, the ground collapsed and swallowed the overlying mountains. The end result was broad, cauldron-shaped volcanic depressions called calderas. Scientists have discovered that the first eruption created a widespread volcanic deposit known as the Huckleberry Ridge Tuff. You can still view this at Golden Gate, south of Mammoth Hot Springs. This titanic event, one of the 5 largest individual volcanic eruptions known anywhere on Earth, formed a caldera spanning more than 60 miles, or 100 kilometers, across. The second eruption was similar but on a smaller scale, although it was still huge and caused havoc in faraway places. It also formed a caldera known as the Henry's Fork caldera, located in the area of Island Park, west of Yellowstone National Park. You can also see the deposits from this event today, called the Mesa Falls Tuff. There was another eruption leading to a caldera about 640,000 years ago, as scientists have discovered. This one, about 100 times bigger than Mount Pinatubo and 10 times more powerful than Tambora, created the 35-mile-wide, 50-mile-long Yellowstone caldera. The pyroclastic flows from this eruption left thick volcanic deposits known as the Lava Creek Tuff, which can be seen in the south-facing cliffs east of Madison, where they formed the north wall of the caldera. It caused huge volumes of volcanic ash to blast high into the atmosphere. Evidence of this eruption as ash deposits can still be found in places as distant from Yellowstone as Iowa, Louisiana, and California. But what was the cause of these explosions? They happened when large volumes of rhyolitic magma accumulated at shallow levels in the Earth's crust, up to 3 miles, or 5 kilometers, below the surface. This highly viscous magma was charged with dissolved gas and then moved upward. The movement placed lots of stress on the crust and generated earthquakes. When the magma neared the surface and the pressure decreased, the gas expansion triggered violent explosions. Other eruptions where rhyolite played a part and formed calderas include the Katmai National Park, Alaska, which formed in an eruption as recent as 1912. In fact, the Alaskan eruption is a somber reminder that Yellowstone can come to life again. Meanwhile, eruptions are not the only devastating acts Yellowstone is capable of. The national park can also cause a lava flow, although the effects would not be as dire as the previously mentioned lava flow. In fact, Since the last eruption about 640,000 years ago, scientists discovered that Yellowstone has witnessed about 30 bouts of lava eruptions. Many visitors hike or drive over the lavas, some of which were deposited more than 160,000 years ago. Some of these lava deposits are very thick and large, covering up to 130 square miles, which is about double the size of Washington, D.C. These lava flows are extremely dangerous because they flow over everything, covering several hundred feet per day for months or even several years. Everything in their path gets destroyed completely. Scientists have modeled what a super eruption in Yellowstone will cause to the Earth. Supervolcanoes are 1,000 times more powerful and explosive than your standard volcanic eruption, so you can imagine the carnage. They eject not less than 240 cubic miles of materials and keep spilling for months. The main damage would come from volcanic ash, a combination of splintered rock and glass, which will spurt miles into the air and scatter around the country. A super eruption can easily bury the northern Rockies in 3 feet of ash. This will devastate large areas of Wyoming, Idaho, Colorado, Montana, and Utah, the ground zero in this scenario. Volcanic ash is extremely dangerous, as it can wipe out humans, animals, plants, and crush buildings. You need just a few inches of ash to destroy farms, clog up roadways, block sewer lines, and so forth. It is also enough to cause serious respiratory problems and destroy electric transformers everywhere. Even air travel will have to pause because it won't be safe. Can you imagine the problems caused by the grid shutting down? Many industries that support many other industries will shut down, likely triggering an economic collapse. The disruption of air travel will also prevent the movement of passengers and goods, which will hamper the world economy. This eruption may kill as many as 990,000 people in the immediate vicinity. Contributing to the death toll is the fact that the ash would block off all points of entry from the ground, and the spread of ash and gases into the atmosphere would stop most air travel. As previously mentioned, this would seriously limit rescue operations. But that is not even the end, because just as frightening is the nuclear winter some experts say could blanket the US and other parts of the world. These sulfuric gases released from the volcano would spring into the atmosphere and mix with the planet's water vapor. The resulting haze of gas that could cover the country will dim the sunlight and also cool temperatures. Do you know what falling temperatures mean? Hunger, because it would wreck our food supply, decimating crops and throwing the food chain out of whack by leaving those at the bottom with little to eat. This wouldn't be different from what many climate scientists believe happened in C.535 after a supervolcano erupted in Java. In fact, in Europe and North America, 1816 was known as the year without a summer because of global cooling caused by the 1815 eruption of Tambora in Indonesia. It caused a large number of crops to fail due to the cooling caused by the eruption. The more recent 1991 eruption of Pinatubo in the Philippines also caused global cooling, perhaps by an average of about 1 degree Fahrenheit during the following year. Interestingly, there will be warning signs before the worst of the eruption hits. We would likely foresee intense seismic activity across the entire park. It could take weeks or months for those earthquakes to break up the rocks above the magma before an eruption. So, whatever we can do to brace for the impact in a few weeks or months could help, or not. Speaking of preparation, is there anything we can do to prevent or avert a destructive Yellowstone eruption? What if we attempt to drill into Yellowstone to relieve the pressure and prevent an eruption? A lot of things need to be considered here before we start moving drilling rigs to the site. Of course, limited scientific drilling for research can help scientists better understand magmatic and hydrothermal, hot water, systems. But when it comes to drilling to mitigate a volcanic threat, that is an entirely different discussion. We are not even sure of what all the consequences would be. There is also the high cost of such a venture, and the government has to consider the potentially severe environmental impacts. That is not to mention the enormous technological difficulties in drilling through hot, mushy rock, basically at near magmatic temperatures and pressures. Any hole you dig would rapidly become sealed by minerals crystallizing from the natural fluids present at those depths. Additionally, Yellowstone National Park is protected from geothermal resource development. World-famous features like the Old Faithful geyser and Grand Prismatic Spring depend on heat provided by the magma chamber deep below Yellowstone's surface, so you can't just start digging. Any allowed geothermal extraction would lower the pressure on the existing geysers and hot springs, and permanently change their behavior. They may even disappear completely. Drilling in Yellowstone in an attempt to release pressure could even have the opposite effect. Scientific studies have shown that depressurization is one of the factors that drives magma toward the surface to erupt. So, trying to cool and depressurize magma systems would have many risks. Since there is basically nothing we can do to stop Yellowstone from erupting, what can you do to protect yourself or increase your chances of survival? Much of that depends on how close you live to Yellowstone. The immediate dangers happen during the explosion itself in the first few days. If you are close enough, you will face two major challenges: your roof caving in under the weight of the ash and killing you, or if you survive, the destruction of your home, leaving you without shelter and exposed. Breathing in volcanic ash will do you in. The first thing is to ensure your roof does not collapse on you, although just how to do that is a big problem. Then, you must ensure you do not breathe in the ash or let it get into your eyes. You may want to invest in industry-grade respiratory filters to filter out the harmful substances in the air when you are outdoors. You also need to wear military-grade eye protection goggles when you're outside, or simply stay indoors where your air is purified. Since the best plan is to stay indoors, provided your abode does not collapse, you need to stock up on everything: food, water, fuel, electricity, drugs, and much more. You may be able to survive until you're rescued. However, the best survival plan is to evacuate the affected areas at the first warning. Meanwhile, even though a possible eruption is more intriguing and grabs the news headlines easily, there is another event that can make visitors to Yellowstone shake, yes, literally shake, because many earthquakes happen in Yellowstone. In fact, in a typical year, Yellowstone National Park and its immediate environment witness between 1,000 and 3,000 earthquakes per year. So at least about 3 earthquakes shake Yellowstone every day on average, making the park one of the most seismically active areas in the U.S. Many of the earthquakes at Yellowstone come from regional faults caused by crustal stretching and mountain building. For example, major faults along the Teton, Madison, and Gallatin ranges pass through the park and likely existed long before the beginning of volcanism there. Any movement along these faults can cause significant earthquakes. The last major earthquake in Yellowstone's recent history occurred near Hebron Lake, which is just west of the park. It was a 7.5 magnitude earthquake and caused damages equivalent to $70 million. It didn't just cause property damage, it killed 28 people. Most of the casualties resulted from a landslide triggered by the quake. Meanwhile, if you keep to the Yellowstone caldera, you would likely be safe from large earthquakes like the Hebron Lake event. This is because geologists discovered they're unlikely to occur within the Yellowstone caldera itself. The subsurface temperatures there are high, and this weakens the bedrock and makes it less able to rupture. But that doesn't mean you are completely safe, because quakes within the caldera can be as large as magnitude 6.5. What's more, Yellowstone is vulnerable to even distant earthquakes. For example, in 2002, the magnitude 7.9 Denali Fault earthquake that struck central Alaska, 1,900 miles (3,100 kilometers) northwest of Yellowstone, touched the active Yellowstone volcanic and hydrothermal system and triggered hundreds of small earthquakes there. The region's hydrothermal system is highly sensitive to quakes and undergoes significant changes in their wake. Earthquakes may have the potential to cause Yellowstone's hot water system to destabilize and produce explosive hydrothermal eruptions. Yellowstone celebrated its 150th year of being open, but it was on a sad note. The park opened the high season with historic flooding that caused damage. Sadly, scientists warn the park management should brace for more flooding like this in the future. So what is going on in Yellowstone with flooding? In the second week of June 2022, an atmospheric river, which is a narrow band of tropical moisture, soaked the Pacific Northwest before dumping several inches of rain on northern Wyoming and southern Montana. This led to the closure of the park, and more than 10,000 visitors had to be evacuated. Many cars were stranded, campsites were flooded, roads washed out, and rocks blocked the way. The management of Yellowstone was grateful for the cool, wet spring earlier that brought much-needed water to the region. The area had been experiencing drought conditions, so the water was welcome. However, things began to change in April. An alarm bell started to ring as higher than medium precipitation in the Yellowstone basin helped build up the snowpack on the ground, which had increased to nearly the 30-year median by May. Between June 10 and 13, the Absaroka and Beartooth ranges received between 0.8 and 5 inches of rain, which combined with 2 to nearly 5 inches of snowmelt. The combination of rain and snowmelt, amounting to 4 to 9 inches, or 10 to 22 centimeters, of rain, flowed over already damp soils that were unable to soak up the water. The runoff deluged the Yellowstone, Stillwater, and Clarks Fork rivers, and their tributaries. The Yellowstone River reached a maximum depth of 13.88 feet on June 13, 2022, breaking the previous record of 11.5 feet set in 1918. The river discharged a record 51,400 cubic feet per second of water on the same day, significantly more than the previous record discharge of 32,200 cubic feet per second attained in 1996. The rising floodwaters completely cut off large sections of the park by washing out roads and bridges, sweeping away multiple houses, and flooding hundreds more. Rock Creek also destroyed several bridges and flooded businesses in the downtown of Red Lodge, Montana. Residents of several towns were hit with power outages and polluted drinking water supplies due to the flood. While the establishment of the park took place 150 years ago, how long have people been inhabiting the park? The answer, according to scientists, is at least 11,000 years. In fact, the park has several names given to it by different tribes that have lived there. For example, the Crow referred to it as the land of the burning ground, or land of vapors, while it was many smoke to the Blackfeet people. The Flathead tribe knew it as smoke from the ground, while the Kiowa called it the place of hot water. However, more than just people from these tribes have made a living off the park in the past in its long history of habitation. In fact, if you hike along some of the modern trails, you are simply following the footsteps of the indigenous tribes that created the corridors dating back to 12,000 years ago, at the end of the last ice age, when humans first appeared in the archaeological record in North America. Yellowstone attracted commerce thanks to its natural resources. It was the source of an important trade item in ancient times, obsidian. If you're wondering what obsidian is, it is an amorphous volcanic glass, a product of rapid quenching of magma upon eruption onto the surface. This item might not mean much to you today, but it was a prized commodity because it was used to create arrowheads and spear tips. There is evidence that for over 11,000 years, the Obsidian Cliff, located in the Norris Mammoth Corridor just north of Roaring Mountain, was a buzzing crossroads of commerce for indigenous people. This resource drew nearby tribes into the boundaries of Yellowstone, and modern archaeological efforts have documented over 50 quarry sites on Obsidian Cliff to date. Obsidian quarried and knapped from Obsidian Cliff has been found as far east as Wisconsin, Michigan, Ohio, and Ontario. Some evidence even suggests that certain tribes, such as the Hopewell people, traded 2,000 miles from their home along the Scioto River in Ohio just to mine the prized obsidian in Yellowstone. But why are indigenous people no longer found throughout Yellowstone? Even though the U.S. government agreed that the Yellowstone region belonged to the various local indigenous tribes, the establishment of Yellowstone National Park in 1872 more or less signaled the end of indigenous occupation within the park's boundaries. Park Superintendent Colonel P.W. Norris was determined to remove indigenous people from the newly established park because he felt they discouraged tourism. Rumors were spread that indigenous tribes feared the geysers and hot springs of Yellowstone. Many died of smallpox, and the remaining few eventually made their way to the Wind River Reservation established southeast of the park. One of the most tragic events to happen in Yellowstone was captured on camera, but the park authorities won't let the footage be shared. If you've been to Yellowstone or seen pictures, you've probably admired the colorful hot springs that dot the park. However, one thing you should know about these waters is that you must never fall inside. A visitor, who we shall not name, learned this lesson too late and paid with his life. The man was visiting Yellowstone with his sister when he fell into a hot spring. Reports show the pair went to an unauthorized part of the park near the Norris Geyser. One of the chief deputy rangers suggested the siblings were looking for a place where they could soak in the water. The tragedy happened when the victim reached down to check the spring's temperature and slipped, ending up inside the water. When rescuers found his body, they could not retrieve it immediately because of a lightning storm. By the time they returned the next day, the body had disappeared, dissolved completely in the highly acidic water. There is acidic water in Yellowstone's geysers and springs because they come from deep underground, where they pick up sulfuric acid before reaching the surface. The sulfuric content is courtesy of microorganisms that break down hydrogen sulfide in rocks and soils. But how did the park authorities end up with footage of the tragedy? The victim's sister was recording on her cell phone when her brother fell into the pool. There are other ways to die in Yellowstone, including falling off a cliff and tubing the powerful Yellowstone River, where rafting is banned due to safety concerns. However, the vast majority of Yellowstone visitors make it back home safely, but it's important to pay attention to safety instructions in the park. Of course, Yellowstone is not the only place where volcanic eruptions with global impact can take place. For example, Krakatoa is still active and can still erupt again. The last time it erupted, the whole world felt it, but the people closest paid the highest price, which is why a warning system is crucial for the area surrounding Krakatoa. Krakatoa is located in Indonesia, and its last fiery explosion claimed the lives of more than 36,000 people, making it one of the deadliest volcanic eruptions in modern times. It all started with little warning signs, like billowing smoke and small, seemingly insignificant earthquakes. These warnings were actually not ignored, but instead of fleeing, the people included the events in festival celebrations. In fact, the natives thought Krakatoa's natural fireworks were a mere lucky surprise, but that would prove to be a grave mistake. Shortly thereafter, the blast sent a cloud of debris 15 miles into the air. The eruption itself was so loud that it was heard some 2,800 miles away in Australia. It was also heard 3,000 miles away on the islands of Rodriguez, where it was described as the distant roar of heavy guns. It was loud enough to shatter the eardrums of people close by. The magma chamber ruptured and allowed seawater to come into contact with the burning hot lava. This created flashes of superheated steam that moved at over 60 miles per hour. The first set of victims stood no chance. The amount of ash and debris was so great that it cast darkness that didn't go away for 3 days. As the volcano collapsed into the sea, it generated a tsunami 37 meters high, tall enough to submerge a 6-story building. As the wave raced along the shoreline of the Sunda Strait, it destroyed 300 towns and villages. The wave is said to have traveled around the globe 3.5 times at astonishing speed, causing tsunamis as far as South Africa and flinging huge chunks of coral reef onto the land as it went. Some of these sections of coral weighed as much as 600 tons. According to scientists, the Krakatoa eruption caused the oceans to cool for as much as a century. In fact, had the volcano not erupted, sea levels might be much higher than what we have today. 45 years later, Krakatoa was at it again with sporadic eruptions underwater. Some parts of the original volcano shot to the surface and formed an entirely new island, appropriately named Anak Krakatoa, or Child of Krakatoa. But Anak Krakatoa would lose part of its flanks in 2018 when Krakatoa erupted again. This small eruption caused another tsunami that killed 437 people, injured 32,000, and displaced more than 16,000 people. However, there is a type of volcano not included in the numbers above, underwater volcanoes. You may not know about these underwater volcanoes because they usually happen far away, but that does not make them any less dangerous. In fact, most volcanic activities happen beneath the ocean. 2/3 of all volcanic activity occurs in the deep sea. How does an underwater volcano form? Actually, there is no difference in the formation of submarine, underwater, and subaerial, on-land, volcanoes. Underwater volcanoes also form when molten rock is produced in the second layer of the Earth's interior and makes its way through the crust. As Tamin Ma, a volcanologist and professor of earth sciences at the University of Oxford, puts it, most submarine volcanism is associated with continuously active volcanism along mid-ocean ridges, where two tectonic plates are pulling apart. The collision of two plates can also cause a volcano. If both tectonic plates are beneath the ocean, the volcano will develop underwater. Over time, they may grow to form volcanic islands. Volcanic activity within a single tectonic plate can also result in the formation of a volcano. This can happen when a hot spot is underneath an oceanic plate, creating a chain of volcanic islands like Hawaii. One of the notable volcanic eruptions is the Hunga Tonga Hunga Ha'apai volcano in the Kingdom of Tonga. In addition to sending ash tens of thousands of kilometers into space, the volcano also caused a horrific tsunami that killed 5 people and sent shock waves across the world twice. This is a taste of what's to come due to its high activity and proximity to human areas. Mauna Loa, the largest volcano, has been consistently monitored over the centuries. Mauna Loa has been erupting for 700,000 years. It is one of the world's most active volcanoes, with the first recorded eruption in 1843 and the most recent in 1984. In 1930, the U.S. Geological Survey published a geologic map of the Hawaiian Islands that shows the many layers left by the eruptions of both Mauna Loa and the adjacent Claw volcano. There are 5 above-ground volcanoes on the island of Hawaii, but Mauna Loa is the world's largest, accounting for more than half of the island's surface area. The volcano has a surface mass of 5,271 square kilometers, 2,035 square miles, and a maximum breadth of about 120 kilometers, 75 miles. The vast majority of the volcano's huge structure is submerged at 56,000 feet. Mauna Loa appears poised to erupt right in front of us, and its odds of erupting again are estimated to be about 100%, with possibly catastrophic consequences according to scientists. Let's go back to underwater volcanoes because you are probably wondering what happens when a volcano erupts underwater. The impact of an underwater volcano eruption depends on its proximity to the water's surface. If the eruption happens at very great depths underwater, then the weight of the overlying water acts as a pressure cap. For example, if a piece of molten rock enters the sea 2 kilometers, 1.24 miles, below the surface, it will come into contact with cold seawater and cool very quickly. The water will get very hot, but it won't turn into steam. The story is very different if the water is shallow enough. The magma starts to heat the water, which is then converted into steam, creating a big volume change. Steam explosions are really destructive because a small volume of water turns into a huge volume of steam. Aside from the risk of tsunamis, the massive ash ejected into the air when an underwater volcano erupts in shallow water can seriously impact people's health. The falling ash and emitted gases not only pollute the air but can affect access to electricity and water supplies. Because they are underwater, submarine volcanoes are challenging to study due to their inherent inaccessibility. Only a few active sites have been studied in detail. However, scientists working on land can learn about the history of a volcano by visiting the volcano sites and gathering data. This can be done using cliff sequences or digging holes and collecting materials. For underwater volcanoes, scientists usually have to rely on marine surveys and mapping technology like sonar. Even the threat of thermonuclear war or global warming would pale in comparison to an event like this, which would produce an ash cloud that would be capable of obscuring the sun. Millions of species would be wiped out over many years of freezing temperatures if this were to happen. While Mauna Loa is the world's largest active volcano, there are certain supervolcanoes that the world should hope to avoid. It turns out that the question with supervolcanoes isn't whether they could wipe out all life on the planet, it's a question of when it will do it again. According to some scientific evidence, more than 95% of the world's plant and animal species may have been wiped out by an enormous supervolcano that erupted 250 million years ago. Yes, you heard that right. Around 200 million years ago, a supervolcano erupted with such force that it wiped out 75% of the planet's inhabitants. It was so massive that it split North America and Africa apart, forming the Atlantic Ocean in the process. The supervolcano, Central Atlantic Magmatic Province, erupted over and over for 600,000 years. And there's bad news for those of us who live in areas where volcanoes aren't a problem. It wasn't that lava had covered everything in sight or the volcanic ash had rained down so heavily that everything was choked. Instead, it was the aftermath of the event, pollution, CO2, and carbon levels soared. The environment had been harmed, and only a few things managed to recover. It's worth noting that after the disaster, dinosaurs were able to evolve and take over before their own tragic end, demonstrating that no one wins for long. However, some rogue scientists believe that dinosaurs were wiped out 65 million years ago by a volcano, not an asteroid. There have been remarkable underwater volcanic eruptions, and we will dwell on their powerful impact next. Let's look at the most powerful underwater volcano ever recorded. In 2018, the largest active underwater eruption ever recorded birthed a giant skyscraper-sized underwater volcano. The insane thing about the eruption is that scientists are still making discoveries about it. What have they discovered? Scientists discovered the 2,690-foot, 820-meter, tall volcano in the western Indian Ocean, off Madagascar, following a puzzling spate of earthquakes that struck near what is usually a seismically quiet area. After gathering geological data, including information from a 2019 underwater survey of the region, the team realized that there was a new submarine volcano about 1.5 times the height of New York's One World Trade Center. What's more, this new volcano draws from the deepest volcanic magma reservoir known to scientists. According to lead researcher Nathalie Foyer, a marine geoscientist at the Paris Institute of Earth Physics, IPGP, at the University of Paris, the source of the magma, that is, the reservoir, is very deep, about 34 miles, 55 kilometers, underground. It was the first time in volcanology that they could see such a deep reservoir at the base of the lithosphere, the outer shell of Earth that includes the upper mantle and crust. Between May 2018 and May 2021, more than 11,000 detectable earthquakes shook Mayotte, a small island and French territory between Madagascar and Mozambique. The most powerful earthquake was a magnitude 5.9, but there were also strange seismic hums, or very low-frequency earthquakes, that originated deep underground. They couldn't be felt at the surface, but they were picked up by seismometers around the world. These very low-frequency earthquakes are associated with volcanic activity. This sudden seismic activity was surprising, given that only 2 earthquakes have been detected near Mayotte since 1972, and until now, the most recent volcanic activity was at least 4,000 years ago. In July 2018, scientists were stunned when they discovered that Mayotte was moving eastward at about 7.8 inches, 20 centimeters, a year, as detected through GPS data. At that point in time, the island had only 3 or 4 GPS stations, so scientists installed global navigation satellite systems and ocean bottom seismometers around the island to learn more about the geological changes occurring there. The findings were extraordinary. The combined land and ocean bottom seismometers picked up 177,000 events between February and May 2019. In any serious discussion of underwater volcanoes, you will hear about Tamu Massif. This water is the size of New Mexico or the British Isles. Tamu Massif is located under the Pacific Ocean, about 1,000 miles, 1,600 kilometers, east of Japan. Tamu Massif is the biggest volcano on the planet and also competes for the biggest in the entire solar system. It is in the same league as Olympus Mons on Mars, which had been considered to be the largest volcano in the solar system. There used to be misconceptions about Tamu Massif. Scientists thought it was a composite of smaller structures, but now they have confirmed that the mighty volcano was just a giant volcano. Tamu Massif is a rounded dome that measures about 280 by 400 miles, 450 by 650 kilometers, or more than 100,000 square miles. Its top lies about 6,500 feet, 2,000 meters, below the ocean surface. The base goes down to a depth of about 4 m or 6.4 kilometers. Tamu Massif makes the largest active volcano on Earth, Mauna Loa in Hawaii, which measures about 2,000 square miles or 5,200 square kilometers, look like a child's toy. Made of basalt, Tamu Massif is the oldest and largest feature of an oceanic plateau called the Shatsky Rise in the northwestern Pacific Ocean. The total area of the rise is equivalent to the landmass of either Japan or California. The name Tamu Massif combines the institution the scientist came from and a French word. Tamu means Texas A&M University, while massif is French for massive. It is a scientific term for a large mountain. Scientists believe that Tamu Massif was created by a single volcano and probably over a short period of time, which actually took a few million years. But on the universe's time scale, where some events take billions of years, it's quite short. The volcano went extinct or inactive not long after it formed, which was probably in the late Jurassic to early Cretaceous period, about 145 million years ago. How did Tamu Massif form? It seems the spot on the sea floor had the right mix of elements, including a boundary of 3 tectonic plates, a thin crust, and a source of hot magma below that was able to bubble up to the surface. The molten rock poured out and then built up a wide, gradual rise as it cooled. However, just how the magma made it to the surface has not been established. Perhaps a blob of the rock got superheated and then rose to the surface due to buoyancy, or cracks in the overlying crust could have opened, allowing molten rock to spill out. And as massive and powerful as volcanic eruptions are, sometimes they go unnoticed, and scientists have to find clues after the fact to piece together what happened. This was a case that made scientists study a floating raft of pumice up to 5 meters thick that covered 400 square kilometers of ocean. Giant hunks of pumice the size of SUVs were strewn across the seafloor, along with a thick layer of sticky ash and 14 lava floats. These are the clues that scientists hope will lead them to solve the mystery of the largest deep-ocean volcanic eruption on record. We'll go back to 2012 when the Hava seamount exploded with a volcanic eruption that was 1.5 times the size of the Mount St. Helens eruption in the United States. No one noticed anything about these outbursts from the Earth's crust until a few days later. That was when an airline passenger looked out the window as she flew over the Pacific Ocean, 800 kilometers north of Auckland. She spotted an enormous floating raft of pumice and quickly took a photo, which she sent to a geologist. Unknown to this passenger, she had set in motion an international effort to solve the mystery of an underwater volcano. Later in October of that year, the NIWA research vessel Tangaroa carried out a scan of the Hava volcano using an echo sounder, creating a map from the data. Scientists discovered that the map was quite different from how the seamount had looked when it was discovered in 2002. This actually confirmed other evidence suggesting that Hava was indeed the volcano that had erupted. 3 years later, a group of scientists headed to Hava, intending to create a more detailed map of the volcano, taking photos, and collecting rock samples. Of course, the evidence of the submarine eruptions these scientists were looking for is hidden beneath hundreds of meters of seawater. This made it very difficult to study, but an invention came to the rescue: underwater robots. The remote-operated vehicle, ROV, Jason was connected to the research ship with a fiber optic cable, allowing the operators to see what the ROV was looking at as they drove it around. The underwater robot was also able to take photos and collect samples. The automated underwater vehicle, AUV, Sentry was pre-programmed to follow a set route as it took photos and measured water chemistry. By the end of the expedition, the team had generated a much more detailed digital map of the volcano. This map revealed numerous lava flows, a widespread ash layer, and millions of enormous pumice blocks up to 9 meters across, scattered over the ocean floor. The robot also collected a number of large pieces of pumice. One of the things scientists tried to discover was the nature of the eruption. Volcanoes could be explosive or effusive. Explosive means the volcano explodes, while effusive means that lava flows steadily from a vent. This is where the scientists found themselves at a crossroads, because the ash supports an explosive eruption, while the pumice and lava point to an effusive eruption. Speaking of volcanic eruptions, Huaynaputina is the site of the largest volcanic eruption ever recorded in South America. The explosion was so powerful that it sent mud flows down to the Pacific Ocean, 75 miles, 120 kilometers away. Scientists even believe this eruption, which happened in 1600, affected the global climate because the summers following the eruption were some of the coldest in 500 years. Ash from the explosion deluged a 20-mile, 50 kilometers area to the mountains west, and you can still see the ash today. Although Huaynaputina in Peru is a lofty 16,000 feet, 4,850 meters, it's somewhat sneaky as volcanoes go. It stands along the edge of a deep canyon, and its peak doesn't have the dramatic silhouette often associated with volcanoes. The Huaynaputina volcano damaged 2 nearby cities, Arequipa and Moquegua, and it took a century for them to recover. The volcanic eruption of Krakatoa was more recent, but no less deadly. It spent months giving warning rumblings before finally erupting on April 26 and 27. The explosive eruption of this stratovolcano, situated along a volcanic island arc at the subduction zone of the Indo-Australian plate, shot out huge amounts of rock, ash, and pumice. The terrifying sound was heard thousands of miles away. The volcanic explosion also created a tsunami, whose maximum wave heights reached 140 feet, 40 meters. The tsunami recorded a death toll of about 34,000 people. More than 7,000 miles away, the Arabian Peninsula recorded an increase in wave heights on tidal gauges. The island that housed Krakatoa was completely destroyed in the eruption. However, new eruptions beginning in December 1927 built the Anak Krakatoa, meaning child of Krakatoa, cone in the center of the caldera produced by the 1883 eruption. Anak Krakatoa now randomly comes to life and builds a new island in the shadow of its parent. One of the largest eruptions in the 20th century was that of Santa Maria in 1902. The violent explosion in Guatemala came after the volcano had remained silent for roughly 500 years. It created a large crater nearly a mile across on the mountain's southwest side. The symmetrical, tree-covered volcano is part of a chain of stratovolcanoes that rises along Guatemala's Pacific coastal plain. It has experienced continuous activity since its last significant blast, VEI-3, which occurred in 1922. In 1929, Santa Maria spewed forth a pyroclastic flow, which claimed hundreds of lives and may have taken the lives of as many as 5,000 people. Another volcanic eruption that changed the world is the Thera eruption in Greece. Scientists believe that had Thera not erupted 3,500 years ago, the map of the world would look different. It is believed to be the single most powerful explosive event ever witnessed. Thera blew a large hole in the island of Santorini and sent the whole of the ancient Mediterranean on a different course. The eruption also had political effects. It completely destroyed the Minoan culture, which was the most dominant in the region at the time. While historians and archaeologists can't agree on the exact year Thera exploded, estimates range from 1645 BC to 1500 BC. But what is not in doubt is the evidence from ash deposits found on the ocean floor showing that Thera erupted with a force that humans have never witnessed before. Piecing together the full picture is difficult because no first-person account of the event exists. However, researchers have been able to compare it against the Krakatoa volcanic eruption. Thera killed more than 40,000 people in just a few hours and generated colossal tsunamis 40 feet tall. It also sent volcanic ash across Asia, causing a drop in global temperatures and creating strangely colored sunsets for 3 years. People heard the terrifying blast 3,000 miles away. Scientists say Thera's eruption was 4 or 5 times more powerful than Krakatoa's. It exploded with the energy of several hundred atomic bombs in a fraction of a second. Interestingly, scientists have not found human remains or valuables belonging to the Minoan residents of Santorini, suggesting they were able to predict the eruption and evacuate the island in time. However, based on evidence from the nearby island of Crete, the powerful Minoan civilization declined suddenly soon after Thera's explosion. Tsunamis spawned by the eruption would have swamped its naval fleet and coastal villages. Historians also believe that the drop in temperatures caused by the massive amounts of sulfur dioxide spouted into the atmosphere led to years of cold, wet summers in the region, ruining agricultural harvests. This lethal combination destroyed every notable Minoan stronghold in less than 50 years. This devastation led to a power vacuum, triggering the free-for-all that became the warring city-state system of ancient Greece, which would go on to dominate the Mediterranean. The Thera eruption turned out to be a fundamental building block for the history of Europe, as the Minoan decline changed its early foundations completely.